Good morning.
Morning. I still see some people settled in the back, but I think we can get started.
Here we go.
Right. So welcome today. Today's session is about building multi-account, multi-region application with Terraform Stacks. Before we get started with some introductions, let's kind of warm up the room, and we have a couple kind of survey questions for you. Karim, you might want to ask these first questions.
Yeah, this is going to be really hard because I'm going to need you to show your hands if you've ever built custom tooling to manage dependencies across different environments, be that production staging, development, be that multiple regions, multiple AWS partitions. If you've done that, raise your hand. Shell scripts count, makefiles count.
All right, yeah.
If you wrote your own binaries for that, I love you, but I'm so sorry.
All right. Let's do another question. This is the question I like. If you consider yourself like platform engineers, you deploy infrastructures multiple times across multiple accounts, multiple regions. Anyone doing that today? Yeah? Awesome. My team, my people. Have you ever heard concepts such as dry, do not repeat yourself? Yeah? And also kind of struggled with how do I do that? And looks like we have a healthy amount of raised hand on both sides, which means you are on the right sections. I'm going to introduce myself now. My name is Welly. I'm a principal partner solution architect at AWS. And here today, I'm joined with my distinguished colleague, Karim.
My name is Karim. I'm a senior developer advocate at HashiCorp, where I focus on infrastructure and orchestration tooling, so tools like Terraform, Packer, and Nomad.
Awesome. So we have jam-packed agenda today. You raise your hands, so you know what you're potentially going to learn today. And in case you didn't really raise your hand on both, stay tuned, because there's a couple things that you might learn today as well. So today we're going to discuss what are the use cases for multi-environment, multi-account, multiple regions, and etc. We're going to also talk about the challenges that happen with that model. And then we're going to talk a little bit about what is Terraform Stacks. And follow with that, we have a cool demo. And we're going to wrap up with a couple more conclusions. So with that, first, I want to talk a little bit about the use cases. Some of you might already be very familiar with this, but for some, this is maybe completely new. So stay tuned. You might hear and learn about a couple things. So when we talk about multi-environments, actually there's two types of use cases typically. The first one is the one I like, platform infrastructures. You deploy some resources, typically like networking layer, security, permissions, IAM roles, and etc. And in here, you're really kind of doing it as consistently across multiple environments, across multiple workloads. And when we talk about this group, really, one of the key items that they really care about is this concept of dry. Do not repeat yourself, how you ensure like you're not copy-pasting the same code over and over and over again. The second thing really important for this types of group is that the consistency, because you are really thinking about dealing with 10, hundreds, or maybe thousands of accounts, and how you ensure that you have that consistency, because you cannot really go to each of the accounts and inspect everything. How are we doing it today? Typically, you have this potential model, like you see in the screens, where you try to decouple your Terraform configurations using modules. And then you have your main deployments, your root configurations, multiple accounts, and then you have a pipeline that then handles the deployments across multiple environments. Now, a couple things in here that I think is key to the challenge for this group. Stage management. You have to deal with that as part of the orchestration itself. And the second part is the actual workflow, navigating through the directories, ensuring like the right account has the right variables, and etc. So this is the first types of the use cases and some of those challenges that we see today. How are we solving this today? AWS has a solution called Account Factory for Terraform, which allows you to build a pipeline, but it's not really something that easy to use per se. Or you can also use Jinja templates and etc. You name it, there's some solution out there. When you look at the second workload, I think a lot of you may have seen something like this as well. When we say about real applications, application today can span across this blurry line between what is called infrastructure and what's called applications. For example, you might have a Kubernetes clusters that's running your Kubernetes workload. Now, at high level, everything looks straightforward for these types of workload, but really, let's take a look. Typically, you have something like this. You have your VPC as your networking layers, and then you have your cluster. That cluster also includes an add-on. Now, if we zoom in on this box, what you will see is that first, you have the cluster that you have to create, and then after that, you have to create the actual service and add-ons. Now, if you're familiar with how Terraform works, you run Terraform plan, what you're going to see is there's going to be a lot of unknown values. For example, for your add-ons, you have to know what is the cluster ARN, or the name of the cluster, or the ID of that cluster. Before that cluster can exist, you have to have the VPC first, which means like you might have seen a lot of this known after apply. You're probably very familiar with this model, where in your Terraform plans, a couple things show up with the values, the rest of it is unknown. Now, if you delve deeper into the application, same thing. Because if you have your pods, you have to have your namespace. Before you have your namespace, you have to have the cluster, and you have to have the authentications to the Kubernetes provider from that cluster as well. So if you look at it, you're going to split this into multiple accounts, multiple environments, then suddenly you have a lot of this dependency that's going to mapping from one to the others. What typically customers do today, what we hear from the customer, is that they're going to slice this into multiple Terraform deployments. First, they're going to deploy the VPC, the networking layers, and then they have another workspace to deploy their Kubernetes cluster, followed by the service add-ons, and then the pods. They have to do this because they want to ensure that the dependency is correctly mapped between each of the stages. Now, if you imagine that, and you have a project that has like 3 environments, then suddenly this matrix starts to grow. Oops, sorry. And this matrix in here, you can see there's a lot of dependency from one project or one workspace to the other workspace. You have to wait for this development to complete, go into the productions. After the production is complete, you go to the DR. If something goes wrong, then the dependency issues in here. This also means like if you want to add new environments, then you have to inject this into this new ordering. You have to deal with this ordering, not to mention the time it takes to actually go through it. So 2 use cases, platform resources, workload resources. At the surface, kind of looks different, right? One is about many accounts, many regions, preferred consistencies. You have large target, and you have higher level abstractions, while the others is workload where you have a very targeted, you have a specific order how you want to deploy your workloads. Regardless, between this platform and the workload resources, there's still challenges in terms like how you manage the workflow and the stage management. All right. With that, if you really think about these issues, it's come to this idea of like, why don't we have a way to declare the deployments? You can declare your infrastructure as the code, but why can't I declare my deployment as the code as well? And exactly that's what we're thinking in here is that let's just have this kind of like pseudo code, as you can see in the screen. We'll say, I want to declare my deployments, specify the input regions, and then I specify the number of these instances, for example. And this is really like what we're trying to build, and the idea is like we don't want to change the existing way you work with Terraform. You're still using the same modules, for example. You don't want to expect you to make any changes to that. But building on top of that, we want to have this another layer of abstractions written as a code to really allow you to orchestrate these deployments. And with that, we're going to introduce you to Terraform Stacks. I'm going to have Karim to talk a little bit more about this.
Beautiful, thank you. So the important thing is that for the past decade or so, right, we've tried to isolate our workspaces. We've tried to make sure everything is neatly separated. So when somebody updates DNS records, they don't actually wipe out the DNS zones, wipe out VPC and everything, even though a single apply would probably be easier. Luckily, you can still have that isolation. With Stacks, you're just able to take it a little bit further. And I want to give credit to our product manager who came up with the idea of calling this infrastructure as code as code. So basically, going next level. Still use your own modules, your old modules, keep maintaining them, keep using them, but add a little bit on top of that. So with Welly giving us a clear understanding of the problem space and workflows, and workflows that may or may not work for what you need, in the sense of, oh, it takes human interaction. Nobody has time for that. Nobody wants to spend time on that. Nobody wants to wait for things to be deployed. Let's have a look at how stacks can solve this. And so a Terraform stack, like your actual application stack, consists of a couple of different units. And the first base unit we're going to be talking about is called a component. A combination of one or more modules, Terraform modules, that define what your stack looks like from a resource perspective. So your RDS, your EC2, whatever else you need and have. A combination of networking, compute, storage, everything really. Add to that a deployment. This unit basically defines how many times a collection of modules and a collection of components gets deployed and how. Goal here is really to repeat the infrastructure provisioning and that part of the whole process while not repeating the code for it, because there's no point. Also, when you repeat code, you saddle yourself up with maintenance burden, because that extra deployment, which has slightly different code than the other one, now basically means you have to go through 2 review cycles. And I'm a very lazy person. I don't want to review the same code twice. But we're not there yet. Writing code is easy. Writing good code is slightly harder, especially if you need to add documentation, which we're all trying to enable platform paradigms, which kind of means that we want to hand off our best code to other people. So write documentation for that. And then you have to invoke it multiple times in a predictable way. Doing that manually is not the predictable way. It's hard, it's tedious, and primarily it's error prone. So we want to get away from that. Where infrastructure really gets interesting is when you define the orchestration part of that infrastructure. We're not talking Kubernetes or Nomad or workload orchestration, but the actual infrastructure orchestration. This workspace should be deployed when that workspace is done, or this resource should be done when that resource gets fully provisioned, and when we have things like an ARN available that we can use to configure things downstream. So in the orchestration unit, you define the checks and the rules that you need to get your deployment out there. And last but not least, of course, and this is one of my favorite features of Stacks, really, is deferred changes. Sometimes you've got this setup where you make a config change, right? Your plan runs, and Terraform will go. There's 27 things that will be known after apply. Terraform really makes an effort to retrieve that information, tries to figure out the relationship of everything, but it can't always. Sometimes it takes 10, 15 minutes to get a cluster. If you're doing HA databases, that time goes up. So at that point, Terraform is blocked. With deferred changes, work can still continue in the background and then get back to the main plan to figure out what needs to be done until you end up at the bottom of our beautiful, not diagram, which is success. It's time for more coffee. Starts with a simple change. Maybe you're deploying an EKS cluster with a workload definition that needs some add-ons, some namespaces, and all those result in delays. Not with Terraform Stacks. Everything just gets provisioned the way you want it. So I think it'd be fun to look at how we can model this, because theory is important. Applied theory is more fun. Maybe we'll throw in a live demo?
I think we're going to do that later on, yeah.
That's going to be troublesome. But so we've got 4 basic units that make up Terraform Stack. So if we look back at the 2 previous examples that Welle mentioned, we've got the core of our application, so VPC, CIDR calculations, regional CIDR calculations, of course, because we don't want to interfere with the Office VPN that's also connected. All the other, here's some people chuckling. You've been there. Yeah, that's a painful part. We can do a self-help group after that. Routing tables, of course, don't forget those. Internet gateways, everything else that well-architected framework tells you to have in there and to make sure. And I know, from the way you raised your hand, everyone here writes very well-defined, very perfect code, right? We all have those colleagues that don't. And that's troublesome. So, IAM modules that define boundaries so people can't break things they shouldn't be able to break. We'll define our access profile. What else? Things that line up with our organization's requirements that make the CISO happy, that end up in you not resulting in getting a news article published about your company. The important stuff, yeah. Permission sets. If you're working with multiple AWS accounts, you should. If you're not, you should. Very important. Permission sets will drastically make that easier. Not easy, sorry. Security is never easy, but it should always be built in a way that you don't want to say no to it, because that's what your security team does. But in our case, we're splitting up our components in a way that logically makes sense. This is one way to do it. As Wally pointed out earlier, this is not the only way. Usually, if you build infrastructure, it will model the way your organization works, because that's what we do as engineers, right? We build stuff that reflects who we are and how we work, how our organization works. And so once you've modeled all your dependencies, you've got your deployment. Networking, IAM, a little bit of extra stuff on there. And we can turn this deployment into a couple of different deployments with deployment-specific variables across all 3 of these, or across 10 of these, or 100. Quick show of hands. Who here knows how many regions AWS has? 26? It's a good guess. If you're not using the beta regions, the first question for that would be, which partition are we talking about? But 26 is good. 29 would also be really good if you do all the beta stuff. This gets insanely complex when you do this for every region. And sometimes you have workloads that require that. Think gaming. Not just static assets. Static assets is easy, right? Throw that onto a CloudFront distribution. Things get super, super easy there. But actual stuff that needs to be calculated everywhere with failover and everything, add in availability zones, yeah, this complexity goes out the door. Couldn't fit that on this slide or both of these slides together. So we'll need orchestration rules for this. But first, let's go back to your application workload example and look what we can do there in terms of modeling it. So bring in VPC, which is the easy part. Bring in our heavy hitter, which is our EKS cluster. And if you've ever written an EKS cluster module, you know there's about 417 different questions that you're going to be asking yourself as part of this process, because you want it to be perfect, right? You want it to be doing exactly what you need. But making it reusable is the hard part. So we have a little bit of a separation of dependencies here going, and we choose to isolate by component type. But cluster alone isn't it, right? We need namespaces, we need add-ons for monitoring. I think you've got the FinOps add-on in your stuff. We had monitoring role-based access, of course. We want to make sure our workloads work, but are properly isolated and easily distributed. I'm the kind of engineer that likes to build stuff that doesn't break at 3 in the morning, because I really don't operate well at that time, which means we spend a lot, I think when we work together, we spend a lot more time thinking about it than actually building it, because writing code is easy, right? Making sure it doesn't break is the hard part.
I just want to add one thing as well. Like, the way we want to model these components in here is to making sure you understand the life cycle of these resources. So life cycle of resources that has pretty much the same. Like, you can likely deploy VPC and IAM role. That could be in the same components. But then if you look at this, what Karim described earlier, there's a separation between the cluster and then the Kubernetes, because in order for you to start working on those Kubernetes resources, you have to have that cluster ready first. That's why we kind of try to kind of visualize these components in here. Back to you, Karim.
Thank you. Yeah, I think to put this how a friend of mine once put it, to do DevOps and to do platform engineering, you have to be platform engineering. You have to feel platform engineering deep inside your heart, because only when you understand how your application pods depend on the namespaces and everything else can you actually model this in a sensible way. And that's your mindfulness tip for today. Be one with your infrastructure by understanding what you're doing before you do it, before your cluster gets to be operational. And just like before, you can package this up for your environment in any way you need. And of course, if you've ever deployed this exact type of setup, you know it's going to break because you cannot configure a Kubernetes provider and the Helm provider until the EKS cluster is done, which means you can't do the namespaces. Are there ways around that? Of course. You could do something like local exec. You could use shell scripts. You could really upset everyone in this room by going even further down the road, but really it's a chicken, meat, egg problem. And we want to avoid that. So bring in a couple of deferred changes and let Terraform Stacks figure out how this can go and how the apply process should go. Terraform for the past 10 years has spent time understanding the relationship of your infrastructure, right? When you do a dynamic reference from one resource to another, that's a relationship. That goes through the graph. The graph figures out, I need to do this first, then we can do this. Terraform Stacks takes that a little bit further. And then comes the easy part. Stacks figures this out, rinse and repeat, 3 environments, different input variables, of course, different region names, but all in all, same code. It's a lot of theory. So sorry for that. I know there's a lot we're packing into this. You know what? I'm super excited for what comes next.
Yeah.
And what comes next is going to be live. So first of all, Willie was worried that this might not work. And I told him it's going to work because the energy in the room is going to be crazy. So if somebody could just go like, woo, Willie.
All right.
See, you know you can fail now.
I know.
No pressure.
No pressure. OK. We always try not to do too much of live demos, but I can just help myself for this. So we hope that the Wi-Fi is going to work well. Yeah, so I think the next part in here, oh, sorry, just the demo. I'm going to switch the screen. All right.
Code readable all the way in the back?
Yep. All good in the back? Someone can maybe thumbs up? Awesome. Thank you. All right. So let's go start with the demo. We're going to coming back to a couple of the theories that Karim mentioned earlier. But first of all, I have 3 components that I want to demo today. First, we're going to look at the infrastructures. Remember, we have IAM roles and stuff like that. Let's try to replicate that in stacks across multiple accounts. And then we'll try to kind of scale that across like a dozen more accounts. And how are we going to do that without typing too many codes? So my first part of the demo, let's kind of get the sense like what is stacks and how that looks like in your Terraform. You might see in some files in here that looks familiar, but not really. First, there's the components, the TF stacks. Remember, Karim mentioned earlier about the components. This is like those resources that share the same life cycles. And then there's the deployments, the TF deploy. This is where you're going to orchestrate the actual Terraform deployments. Of course, there's the outputs, providers, variables, etc. So first, let's have a look at our components. Now, imagine we're going to do this a little bit more simpler. I don't have my VPC and stuff like that. I just have an IAM role. I've been tasked with my team to kind of create a new IAM role that will be deployed across multiple accounts. Well, so you know that this is real. I'm not doing a video. So as I mentioned earlier, we have this IAM role, right? So this IAM role, I copy-paste from my other talk. Now you start to see something similar, main TF, outputs, and etc. So the IAM role itself is pretty much straightforward. I just have 2 IAM role, one for what I call my security scanners, and the second one is for my FinOps scanners. So imagine like I have maybe 2 SaaS providers I'm going to use. I need to deploy this across multiple accounts. We're not really going to dwell into what this code is, but yeah, you see the main TF, outputs, and my input variables. Very straightforward, yeah? So really what I do in my components, I just model that. Say I want to use this IAM role, I want to deploy this, and then I start to providing the inputs, as you can see on this line in here. The left side is the input variable on the module. And then on the right side is the variables that I will declare at the stack level. So imagine like left side is what the actual variable names in the module. And the right side, which is this part in here, is what available at the stack level. So I specify my source, my input, and then I specify my providers. Because in my IAM role, I'm using two providers. So I say I want to use the AWS and random. So again, I'm specifying on the left side, this is the AWS provider will be used inside of the module. And then on the right side, this is kind of new, right? We say provider.aws.configurations. So let's take a deeper look into the provider block in here to see like what is actually we doing in here. So on my provider.tf stacks, you see again something that's kind of familiar, right? You specify the required providers, et cetera, et cetera. But then in here, things start to get a little bit more interesting. One, I have my provider block, but then I can name it. I call this configuration. And then I have this new config block with the number of regions or the region I want to deploy to. And then some of the stuff that you typically see, assume role with web identity, because I'm using HCP Terraform. And in HCP Terraform, I can assume a role so that I don't have to hard-code the credentials. With that, also the default tags. The provider block for the like a random and the local, I'm not doing anything special in here, so I'll just keep it like that. So now the fun part, how we model the deployment. So this is a very simple example. I have two accounts, account 1 and account 2. For the first account, I'll say, all right, we're going to deploy to this region. So I specify the inputs. I'm going to deploy to region US East 1. This will be the input to the provider block. As you remember in here, I specify the region based on the var region. So that's how it gets to the input in here. Same thing with like the role arm. Because I'm going to deploy this using existing IAM role so that HCP can assume this role. Also specify the account ID where the role will reside. And then more importantly, this is that two inputs that we're going to pass on to the modules. I specify the value of this input in here as well. Now, if I have two accounts, what I can do is that I can replicate that in the second accounts. In here, remember, I don't have to copy-paste that same modules and declare it again, etc. I'm just saying, like, hey, based on the components that I have in here, replicate this for the second region or the second accounts. I have the region again, I have the role, and all of the inputs. So now I have two deployments. And if I want to, I think Karim already mentioned about orchestration. Like maybe you are too lazy, you don't want to like review across hundreds of accounts. What you can do is that you can also allow...
I think I prefer the term optimized workflow.
Optimized, yes. Not lazy, optimizing, exactly. And what you can do is that you can set up orchestration rules to say, hey, let's approve all plan because I trust you. And in this case, the conditions say, if the context of the operation is planned, we will auto-approve it. I can also be more specific. For example, I can say, if this is special account, that I know is maybe part of lower environments, then I will auto-approve based on certain context, where in this case, the context is that is the plan, and the deployment name is account number 1. All right, so we see how we model the component. We see how the provider is being declared in here, and we see what the deployment looks like. So let's now jump to the HCP Terraform and see how we actually going to use it. So already pre-login to my HCP. I have my project, HCP Terraform, in here, and I have my project called reInvent 24, right? And then I'm going to go ahead and create a new stack. So with stack, I'm connecting to a repository. So connect to GitHub, and I will use my repo in here. We call that infra1, so I'm going to go ahead and use that. I can choose whether I want to trigger this based on tag or branch. For now, I'm just going to use the branch. I'm going to use my develop branch. Go ahead and create the stack. All right, I just create my stack. So what do you see on the screen right now? You see on the top, stack will start to fetch that configurations from the repository. And then underneath that, this deployment rollout in here, this is where we're going to see the actual deployments. So now, let's go ahead and try to look at the configuration itself. Okay, so I'm double-clicking into the actual configurations. Now I can see, all right, this is the source of my commit, which I do a couple hours ago. And then I'll see that 2 accounts. Remember, we have in the code earlier, account 1 and account 2. Now that is showing up in here as the deployments. So the deployment name in here is really pretty much a replica of this deployment in here, account 1 and account 2. All right, now looks like I have some actions in here. Let's take a look. First, on account 1, I can see that Terraform Stack is able to perform the plan. Here's my inputs. This input is again based on that same deployment block that I declared earlier. And here's the plan output. We're not going to really go too much into it, but this is the output of the plan. Say I'm pretty much OK with this. I want to go ahead and I approve the plan. Right. Right, so the first one is done. Remember, because I don't save the orchestration rule, so it's still asking me for approving the plan. Same thing with the second one. I can go ahead, and now I'm kind of dive a little bit deeper into the actual deployments itself. So this is for account number 2. Again, similar inputs and the plan. I'm happy with this. I'm going to go ahead and approve the plan. Here I can also see the timeline, like when this configuration is fetched, and then who is approving this configuration as well. So from like single pane of glass, I can see all of that. All right. So it's just an IAM role, so it's very fast. I can see immediately in here account 1 and account 2 is showing up. And if I go and look at this deployment in here, I can see that first Terraform will do the plan, finish with that, apply the configurations, and then it will run another plan to ensure that everything converts, there is no drift, and etc. And I can see that in here as well. Now, this is cool. If I have maybe 1 or 2 accounts, I can model it like this. But what if I have dozens of accounts, right? Hundreds. Anyone in here have maybe a couple of hundreds accounts? Raise your hand, perhaps. Yep, I see a couple in the audience. So now let's take a look at the second model. So suppose that I have maybe a dozen of accounts that I want to deploy, and I model it using AWS organization, so it's based on the OU structures, organizational units, right? On my second demo, everything looks the same. My components, nothing changed. It's exactly the same copy. I'm still using the same IAM role and everything else. My deployment, now things get a little bit more interesting. I can use local, so I'm going to use local, specify the regions, and etc. But also specifying like this map of OU for dev and productions, and then have like a list of accounts for each of them. If I want, I can actually push this to HCP as a variable sets and have that variable set driven by like a data source from AWS organizations. For simplicity, I'm just going to put it in the map in here so we don't have too many components to look at. So let's look at how I model my deployment. This is what I really like about Stack, is the flexibility. Here, I say my input is the region, and then I have several accounts, it's a list, that I derive from this local OU dev. If you look at in here, this is the OU dev and the list of the accounts. The rest looks very much the same, but how are we actually using these accounts? Let's take a look at our providers. So what's really cool with Stack is that I can now start to use more expression in my provider. So what I do in here, I use for loops each. So for that list of the accounts passed from the deployment, right, for the OU dev, for example, I'm looping the provider, and then I specify the region, and that allows me to have like a more expressive way to specify the role on, essentially. If I want, I can maybe double click on this and say like, it's not only a single list, but it may be a complex map where I have like for loop for the accounts and then also for the region, for example. But for simplicity, I'll just keep it as is like this. Now, let's take a look again how this works inside of the stack. So for that, actually, I already configured the infra 2 in here. Don't have any deployment. I can see on the bottom, it's still empty. Let's go ahead and fetch it. All right, it's going to take a couple seconds for it to fetch. And here we go. So I'm going to go ahead and look at the configurations. Yep, Wi-Fi a little bit slow, but this should show up. All right. Now, Stack starts to pull those same configurations that you see earlier in the screen. And now my deployment is abstracted at the OU level. So I have like a dev OU and production OU. So earlier you see like I have account 1, account 2, and etc. Why? Because I'm an infra guy. The way I'm looking at the consistency of my deployment is based on certain OU, like what's in the dev, what's in the prod, for example. So if I look at my dev OU, like first I have the same inputs, like say all of these accounts I want to go through, and then what's the value for that? Because for dev, the FinOps scanner is not running, but the security scanner still runs. And what I can see in here is that Stack will automatically, using that for each, to render the deployment of my IAM role across multiple target accounts. So I can see this is for account number 1, the second account, and the third one. I'm happy with that. I go ahead and approve the plan. And Stack will automatically go and then start deploying across those accounts. Can do the same for the second one, so I want to just go ahead and again, you see a different list because I have a different list for my OU, dev, and productions. Again, I'm going to go ahead and approve it. All right, so with that, that allows me to really model my deployment for multi-account, multi-regions in the infrastructure platform by using a single, like a components and just like a 2 deployment script. Now, the last thing I want to do for the demo, I think we're a little bit short on time, so try to keep this one fast, is that second model that Kareem mentions, the Kubernetes applications. So how we do that, right? First, we have a couple components, like the VPC components. Of course, you have to have the network. And then you have your EKS component in here. So hopefully by now you start to get familiar with how this works. I want to do it multi-region, so I can actually do for each in the component as well. Again, this is really where that flexibility of HCL that you typically do really surfacing again inside of the components, deployments, and also on the providers. So by just this one single line in here, I'm basically telling the stacks and the component, this component in here actually going to span across multiple regions. And then I specify the inputs such as VPC ID and etc. What's really interesting in here, if you pay attention to this part, this component is actually taking dependency from the VPC earlier. So this VPC has to be created first, and then the EKS will take the dependency of VPC from the VPC components. And same thing with my, say, Kubernetes resources like RBAC. It's going to take the EKS component first, followed by the add-on, and etc. So you can see in here, like we are building a dependency within the components as well, and we'll see how Terraform Stack will actually mapping those dependency. We're not going to go and look into each of these sub-modules, but really this is like your regular VPC modules, your EKS, and etc. Nothing really special in here. As you probably know, deploying EKS cluster takes 20 minutes. I'm not going to wait and have you sit in here waiting for me for that. So we like a little bit cheat so far. So I just push that configuration. I take this recording to kind of just speed up. Right? You can see in here that I have 2 deployments for development and prod. My dev is already done a couple hours ago, so I'm not going to see any changes in here. But for the productions, I can see that there is a new plan that's coming up. So let's take a look at this plan value and see what's the result. Now you can see in here, like Stack start to model the components. First the VPC and the EKS. Not only that, you can see like you're able to actually do full plan for the EKS and also the VPC. But there are other components, such as the Kubernetes resources, that's still called divert. Notice in here, there's a line called divert. And that's because, again, if you remember all of those components, a lot of this value is still unknown at the time the Terraform running it. So Terraform Stack is smart enough to say, we're going to wait until the other resources is fully deployed, and then we run again the plan automatically. You don't have to do anything. You can grab a coffee or something. And after that, it will come back to you and say, hey, Welly, I see all of the results. Here's all the full dependency. Are you okay to go ahead and not? So I'm going to hit approve in here. That's just to build the first part of the component, the VPC and the cluster. Again, we're going to speed up this recording in here. You're going to see that the VPC resources will be created magically. And then after that, there we go, that's the VPC part, right? After VPC is done, the EKS cluster can be planned and approved as well without any additional dependency from you. So you can see in here, Terraform Stack, go ahead and start creating the EKS cluster. Follow with that. After the cluster completed, this again takes maybe 10, 15 minutes. We're going to fast forward this recording, and magically you will see the EKS cluster is done. Then the other components, such as the Kubernetes cluster, now can be fully planned. Now, what the Terraform Stack will do for you is that it gives you another converged plan. So I can click in here. Now I can see the full plan because I have my detail of my VPC, I have detail of my EKS clusters and everything else. So if I go and click deeper into, for example, other components outside of the cluster, and you can see in here for my Kubernetes, I can see the actual full plan output, what these resources will do. And if I'm feeling good with this, because this is production, I really want to make sure I look at all of this, plan, review, and then approve it, right? By doing that, now I can start to complete the deployments, and I can see in here all of the history of the changes. And after this is completed, later on, Stack will also do additional convergence in order to ensure like everything done correctly, so there's no drift and etc. So the final thing after all of these resources is completed, we'll see that the Stack will do the final plan just to give you an idea about the final result of it. Right, so you see in here, say, all right, we're done, we applied successfully. Let's look at the plan 1.3, which is like a final convergence. Let's just do a final drift, making sure nothing is breaking, there's no new resources get introduced, there's no drift, and etc. All right, and then you will see very shortly in here that after that's completed, that's going to conclude part of my demo. Okay, I'm going to cut this just to save some time. Let's move back to the presentation. All right, let's do a quick recap. So, apart from a little bit the issue early in the beginning, what do you see? So, you see in here, Stack is very powerful in a way for you to represent the deployment in the declarative way. For example, you can see that you don't need to repeat those infrastructures for like a platform resources, right? I can declare it once, and then I can have multiple of these stacks at scale from like 1 or 2, dozen, and 10 to hundreds, and etc. But beyond that, Karim, I think you also see something very interesting in here, right?
There's a couple interesting things that you get to see. If we can briefly go back to the previous slide, there's one thing that's worth pointing out to add to what you said earlier. We predefined 4 account IDs, right? Hard-coded in there, not dynamic. Works for a demo, but it's probably not going to be what you have in production. As Veli mentioned, you can pull those details from a variable set, which you can fill with Terraform. So you can use the Terraform Enterprise Provider for HCP Terraform, populate your variable sets with the output of a data source. So you could take, for example, as we talked about earlier, all the AWS regions, get a dynamic list of that, or retrieve availability zones, or account IDs, anything that you really need, that you need to be reliable, and that probably should not be done by a human copy-pasting things from left to right. You can just fill in dynamically. And that is a lot of fun. So if we go to the next slide, thank you. That's going to be easier. So we've got our stack. We've orchestrated the deployment of our EKS cluster. Each cluster is networking. Each cluster has all the add-ons, all the configurations, and everything in there. Altogether, this is 18 components in total across 3 environments that we map to dev, prod, disaster recovery. But really, the reason we map it to 3 is because that's the screen estate we have, and it could be way, way more. Which really brings us to the last part of our presentation. Terraform Stacks gives you a lot of operational efficiency gains. Biggest thing, I think, the biggest core tenet I see is the scalability. We do all of this with a few lines of code. It's a superset to the modules you already have. If you know how to write Terraform, you know how to write a stack configuration. It's really that simple. It's actually harder for us to connect to a screen than to write a new stacks configuration, as you could see from the live demo, which I want to point out actually worked. And the only part we skipped through was the things that take longer. Operational efficiency is important, right? We don't want to spend time debugging because debugging takes way too much time. It's error prone, and if we didn't figure it out the first time, it's going to take us longer the second time. So scalability and the ability to just spin up new regions, be that a full region, be that parts of a region, be that an actual new partition. These are important. And the config structures around that in Terraform Stacks allow you to very rapidly do that and repeat your infrastructure without repeating your code. Improved visibility. This is one that I really care about. This goes beautifully with the HCP Terraform Explorer. Just being able to see what your Terraform infrastructure and landscape and cloud real estate really is doing. Are you using outdated modules? Are you using outdated providers? How do you deal with that kind of drift? Well, it gets a lot easier when everything is orchestrated in this way. You saw Welly define a couple of different providers. So we know, for example, the base version of all the AWS stuff is going to be 5.7 for the provider. And that's incredibly important because that predictability lowers the maintenance burden. And then, of course, consolidation. Deferred changes allow us to work with configuration in a more streamlined way. You no longer need to wait for everything to work out, and you can make changes based on events. And that's nice. I like those orchestration rules.
The other thing I want to point out as well, like I think Karim mentioned earlier, is that you have a single pane of glass of the entire deployments. You're not looking at different workspaces, different pipelines, and etc. Everything is actually abstracted into one single user interface within the stacks itself. So from there, everybody in the team has the full visibilities, like we are deploying to multiple OUs, multiple regions, and etc. And it's so easy for you to just adding a new regions or new accounts without having to duplicate a lot of codes, which can be also very error prone by itself.
Now, if you remember at the beginning, we asked who here built custom tooling, who here built a couple of shell scripts. All those approaches are valid, right? It's never about the technology because we always had the technology to do multi-account, multi-region deployments. Terraform Stacks just streamlines it and makes it a lot easier, putting you in a position where you don't need to maintain that tooling, which I think is important. Because ultimately, when you think about modern applications, standard application has between 30 and 100 secrets. You need to deal with different legal concerns, GDPR in Europe, NIS2, all the stuff that you have going on here, and all the beautiful acronyms that take you away from having fun stuff, like actually experimenting with your infrastructure. Getting that overview and getting all of this locked in is very nice. So I definitely encourage you to think about this a little more. And I think we didn't talk about it here, but at HashiCorp a couple of months ago, we announced change requests for your workspaces. So when you're doing large deployments, you see somebody using older providers. You could go in and fix that, but that puts the maintenance burden on you. Make sure that team knows that they need to fix it, and now you're sharing that burden. You're both investing in making your infrastructure much better and more reliable and more joyful to maintain, I almost want to say.
So I know, Karim, everything you saw earlier today is part of the Terraform Stacks that's also available in HCP Cloud Platform or HCP. Karim, why don't you talk a little bit about what is HCP?
So HCP is really a streamlined way to get all your infrastructure needs solved. Obviously, that's a marketing approach, but if you think about it from the left to the right side, infrastructure as code to deploy your resources, to configure your servers, to do everything around that. Bring in Packer, so when you boot up your EC2 instances and your EKS instances, your AMIs already have the right agents and configurations pre-installed. Waypoint, of course, we talk a lot about platform engineering. We talk a lot about building really, really cool stuff. But we also know when you're building anything that has the word cluster in it, there's going to be 50, 100, maybe 200 configuration options. Many of us understand that, but not everyone in our organization does. With Waypoint, we can expose ways that have way less knobs and way less levers to fill in when you use a module like that, making it drastically easier for somebody to consume your work in a much more sensible way. And then, of course, if you don't want to deploy EKS, you need to run workloads that are not containerized. You need to run stuff in different ways. Think Java application, legacy. If you're lucky to work for one of the financial institutions that still use Fortran, congrats on job security. Nomad would probably be a good solution for that, because containerizing a Fortran application is not what you want to be spending your time on. We know this because we had a colleague try that. Rest in peace. He's now a sheep farmer. Anyway, moving on. So our infrastructure portfolio really, really helps you with the whole life cycle, but it's not the whole part, of course. There's also a large security component. So as you build your deployments, think about how you get secrets into things. Think about your secrets management, your certificate management. Vault, I think, is a really great approach for that, especially when you pair it with Stacks and get things and secrets in and credentials in at the last possible minute with the strongest limitations that you can define. But all of this is really a journey. We've been around for 10 plus years. We've seen our customers go through these journeys. It's not something that happens overnight, right? Even if you pick up Stacks right now, it's not a silver bullet. It's not going to solve all your problems in 6 lines of code, because you'll have to think more about your infrastructure. So it will be a journey for you too. But that's OK. You don't have to do it alone. We've got ideas, tutorials, blueprints, everything around this on our website on developer.hashicorp.com that you can download and see what we've learned over the years, so you don't have to learn it the painful way. Then, when you get to the standardizing phase, you're enabling yourself to get more into the whole platform engineering aspect. You're enabling your teams to consume your work. And I think that's where the fun starts. Because ultimately, you get to the scaling part, right? Doing a single stack across a couple of regions, very cool. Doing a single stack across a couple of regions with a couple of environments, also cool. But if we're talking less than 100, come on, rookie numbers, right? Let's go big. Let's add a couple hundred accounts. I saw somebody raise their hand for a couple hundred accounts. I'm so sorry. This is an overhead that is going to be hard to work with, but it's not impossible if you can trust that your code is actually the same across all of these. And, well, I'm just glad we have some tools that work with that and work for us in that setup. Which really brings us to our last slide. Oh, one more, I think.
I think we have one more slide.
Yep, there we go. Everything that Wally showed you today is actually available on GitHub. I saw some people take pictures of the code. That's OK. You don't have to retype it unless you really want to. It is certainly educational, but you can also just clone the repository we have online. Has all the code in there. It will deploy it for you. Should probably mention that these resources are not free. So if you run it in your AWS, in your personal AWS account, that's on you. But at least learning, is something you can do at that point.
Yep. We also have like a lot of documentations, a lot of this concept that we just introduced to you. I know there's a lot of components, deployments, the new provider block, and etc. Go and check out the documentations to really kind of learn more about this. And you will soon realize like it's really just an additional abstraction layer. You don't have to change the way you modify and use your Terraform modules today. There's also additional tutorials that you can take a look in here. So I highly encourage you to look at it as well. Of course, HashiCorp team will be in the booth. If you have any questions, hit us on there. Don't also forget to fill in the survey. I think that concludes the end of the presentations. Again, want to say really thank you so much for staying with us. We're going to be sticking around for a couple more minutes. If you have any questions, after that, we're going to be in the hallway. Karim, anything else you want to say?
Yeah, I just want to say thank you to the producers for getting our technical issues fixed. As you can see, multi-account, multi-region is much easier than actually figuring out how to do slides correctly. So thank you.
All right, thank you so much, folks.